Hello everyone, good afternoon and welcome to the class. So we are covering this 1000 question series, right? And we have completed few subjects and right now we are going on with DBMS and it is also about to get over. Good afternoon Deepak. So this is the Telegram group that you all can join, and there is Android app as well. Okay, everyone. So you can search on your Play Store Digimento Education and you will be able to download it. Okay, so there you have all the courses and everything that is required. So please do join the Android app as well. Do install it in your phones if you have Android phone. Okay, just search for Digimento and Digimento Education name is there, so you can download it, and from there you can also view your courses and other things, right? Okay, so and if you have any doubt, anything, you can always call on these two numbers or you can even WhatsApp on them. Okay, good afternoon Soumya, good afternoon Madineni, and good afternoon Kirti. So yesterday we have discussed few questions and I gave few questions as homework, and I hope everybody has done those questions. Let me just see. Yeah, okay, so this one was first question that I gave. Good afternoon Priyadarshini. Let's just wait for a few more minutes and see. So this was your first question that I gave as homework. Good afternoon Jyoti. So what is this? The relational algebra expression equivalent to the tuple calculus relation. Good afternoon Tikenjit. So this is the tuple calculus relation given to you and they are asking that which of the following is the correct, correct relational algebra expression. So good afternoon Nirmala and good afternoon Venkateshan. So what do you think is the answer for this one, everyone? गुड आफ्टरनून रोहित. यस, क्विकली आंसर दिस एवरीवन. ये तो होमवर्क था, जल्दी जाना चाहिए. So what they are saying and, okay, so they are saying that you have A and B tuples, and from tuple A you are taking the value 10 and from tuple B you are taking the value 20 and you are taking and of them, right? So you are basically selecting something. So T is a tuple, you can say, and from that basically it belongs to relation R. Okay, so whenever we have this and and I think it's basically your intersection. So correct answer is option number C. So this is very basic. इसके लिए कोई ज़रूरत नहीं कि if you don't have knowledge also of tuple, then there is no problem. It is basically they're asking that whether you know the meaning of this and or not. So basically and is what is your intersection. Okay, now consider the join of relation R with relation S. If R has m tuples and S has n tuples, then maximum size of join is. So these basically are your sort of statements that you should know when you start with your subject. You always should know what these statements are. Okay, so consider the join of relation R with relation S. If R has m tuples and S has n tuples. See, when I give the homework, try to give the answers very quickly, okay? Because जितना ज़्यादा time लोगे उतने ही less questions you will be able to do. So try to give the answers quickly, everyone, okay? Otherwise, I'll just not wait for the answers and I'll move forward. I'll simply give my answer, give my explanation, and I'll move forward. So try to be fast so that it will increase your speed only for doing the questions in exam. So the correct answer for this is option number A. Okay, so whenever you are talking about join and you're asking the maximum size of join, it is always m multiply n. So m is your tuple in relation R and n is your tuples in relation S. Okay, not m plus n by 2, it is simply m plus n. Sorry, m in multiply by n. Now, so this question is in tuple relational calculus, P1 is inferred to P2. Okay, so what is this logically equivalent to? P1 is inferring to P2 and it is equivalent to see this statement, this P1 infers to P2, ye aapne, you have done this in discrete as well, and the meaning in both the, whether it is discrete or DBMS, it's always same. Okay, हाँ जी, हाँ धनश्री, right. ठीक है, so P1, when we talk about discrete, what we write it as? We write it as P1 complement or P2, right? This is what we say, or you can say like P1 complement plus P2, right? So the correct answer is option number A. So whether it is tuple calculus or it is your discrete, whatever it is, you will always have the same representation for this inference. Good afternoon Birpal and good afternoon Kokila. Okay, chalo, moving forward. Now from here we have started our transaction and concurrency control. Very easy. ठीक है, कुछ भी नहीं है इसमें. So basically they have said that let S be the following schedule of operations of 3 transactions T1, T2 and T3 in a relational database system. So this is the transactions how they are given. ठीक है, schedule है ये आपका. Now they are saying that there are 2 statements they have given. P is S is conflict serializable and Q is if T3 commits before T1 finishes, then S is recoverable. So try it and then I'll explain. Yes. इतना time. So now first what we will do, first you have to see whether it is conflict serializable or not. So simply we will do what? We will draw T1, T2 and T3 because we have 3 transactions, right? So we will draw these. Now what we can see, now we will try to draw the precedence graph as you say. So what it is, it will be like this one. I think you all have drawn this. So it will be this, this and this. Yes, this is what everyone is getting. Good afternoon Priyanka. Right, this is what everyone is getting, and if you see there is no cycle, and when we don't have any cycle, so then in that case it is conflict serializable because there is no cycle. So statement P is true. Yes, then they're saying if T3 commits before T1 finishes. Now what you can do, how you will try it and how you will see that whether your schedule is recoverable or not. So for seeing whether this is recoverable or not, what we can do, we can try and write the transactions in a form of T1, T2 and T3. Okay, so let's do it. So we have 3 transactions, T1, T2 and T3. Okay, so we will write these schedules one by one. So first thing that is happening is read Y. So read Y is done by T2. So this one, so I'm simply writing it in the order they have given to us. Okay, they have given us in one line, and in order to explain, that is why I am writing like this, so that you can understand what I am trying to tell you over here. So they have given us the schedule something like this only. Okay, now what they're asking that if, what they said, if T3 commits before T1 finishes, right? So this is what they have given to us. This is what they are saying, that if T3 commits before T1 finishes, then S is recoverable. So now how will I say that whether S is recoverable or not? So what is the property when we say that a schedule is recoverable? So remember this, that schedule is recoverable, any schedule S is recoverable when. So this is the basic definition of recoverable. When, so if it is basically, if Tj, okay, we have any transaction Tj creating a dirty read. Now what is dirty read? Now what is dirty read? Okay, it is by reading, here what they're trying to say is by reading a written data by Ti and Tj commits after Ti commits. Now what they are trying to say with this definition is, if you try to understand it, they are saying that if I have two transactions Tj and Ti, okay, so let's suppose here they are saying that T1, that is your Ti is T1 and Tj is T3. Now what they are saying, that a schedule S is recoverable if Tj creating a dirty read. Now what is this dirty read over here? What they mean by dirty read? It is by reading a written data. Matlab ki T3, is there any data that T3 is reading which is written by Ti, that is T1. Trying to understand this point, what they are saying, schedule is recoverable only when, agar if there is a dirty read in Tj. Now what is dirty read in Tj? That Tj is reading a data item, this data item if you see, which is written by Ti. So this is what they are saying. So T1 wrote X and then Tj jo hai, Tj is reading X. Okay, so this is your what? This is your dirty read for this example. Okay, and Tj commits after. So what they're saying, that first your Ti should commit, like somewhat over here, and then your Tj should commit. If we are having a condition of dirty read is when ki agar if I'm talking about Ti and Tj transaction, and in that case Tj is reading a data item that is written by Ti before, and Tj is committing after Ti has committed, then only my schedule S is recoverable. But what they are saying, that T3 is committing before T1 finishes. So this statement, according to this statement, my schedule S is not recoverable. I hope you got this point, everyone. समझ में आया कि not recoverable क्यों है? All those who are saying option A, I hope now you got this, that why this is not recoverable. So you have to know this basic definition of recoverable, that when your schedule is recoverable. And basically they are saying the opposite thing. They are saying that T3 that is doing a dirty read should commit before. So that is what where it will not be recoverable. Clear, everyone? So that is why statement Q is false. So the correct answer will be P is true and Q is false. Okay, now very easy. Let RIZ and WIZ denote read and write operations respectively on data item Z. So basically they have given the definition of read and write. Okay, so they have given you two schedules and you're asking which one is conflict serializable and which one is not conflict serializable. Good afternoon, Devendra. So let's talk about S1. We have two transactions, T1 and T2. Right? So 1, then 2 we have, okay, then 1 and 1, no problem. 1 and 2. So 1 say 2 we'll have one arrow. And then 2 say 1 we will have another arrow. So this is basically what? This is a cycle. And when we have cycle, so it is not conflict serializable. Right? And then we have what? Then we have S2. So let's talk about S2. S2 again we have T1 and T2, and the diagram for S2 will be, I think it will be 2 to 1 only. Yes. So this is, there's no cycle, and when we don't have any cycle, it is always conflict serializable. So answer will be option number B. That is S1 is not conflict serializable, but S2 is conflict serializable. Good. Now, next, assume transaction O holds a shared lock R. Okay? If transaction B also requests for shared lock on R, it will. So what will happen if this is the case? Good afternoon, Pratibha. So here they have saying that they are having a shared lock. So what is the property of shared lock? If you see, the correct answer will be option number B. That is immediately you will grant. So what is the property of shared lock? Shared lock exists when two transactions are granted read access only. Okay, when you are having read access, then only you will be granted the shared lock. Okay, so one transaction gets the shared lock and data, and when the second transaction requests the same data, it is also given a shared lock. Both transactions are in read only mode. So now they're saying transaction A is holding a shared lock R. So if transaction B also requests for shared lock, it will immediately be granted. Why? Because shared locks जो हैं आपके, you can grant them immediately, but they should be in read only mode. Okay. Now next, when transaction TI requests a data item currently held by TJ. ठीक है, try to understand it very clearly. When transaction Ti requests a data item currently held by Tj, Ti is allowed to wait only if it has a timestamp smaller than that of Tj. Otherwise, Ti rolled back. This is what? So this is basically a definition. Okay, can you tell me that what are these for? This question is related to which topic? Any idea? This is basically deadlock prevention. Okay, the deadlock prevention schemes on database when we talk about with respect to database. Okay, good afternoon Aarti. So now what will be the answer to this question? टाइम स्टैम्प भी बोल सकते हो, बट टाइम स्टैम्प में क्या है कि यहाँ पे बेसिकली वी आर टॉकिंग अबाउट टू transactions, that is T1 and T2, and here they are talking about ki what will happen, whether one will roll back or one will wait or there'll be a deadlock type of situation. So in these type of things we are considering timestamp, but it is basically deadlock prevention techniques. Okay, there. So now we have two deadlock prevention techniques. So first you give me the answer of this question and then I'll discuss it. What are they? For database, what is the answer to this question? Correct. The correct answer is wait die. Okay, so we have two basically. First is wait die and second is wound wait. Okay, so there's nothing as wait wound or wait. Okay, we have two only, wait die and wound wait. So your wait die जो है ये है आपकी एक non preemptive technique and wound wait is a preemptive technique. Okay, so this is the definition of wait die. So what they're saying that if your timestamp, if the timestamp of, suppose I'm saying that I have T2 example के लिए, let's say that I have T2, T4 and T6, that is a transaction timestamp 2 है, transaction 4 with timestamp 4, transaction T6 is timestamp 6. ठीक है, so now what will happen is कि suppose transaction Ti, suppose T2, okay, let's talk about this. So T2 is requesting a data item currently held by T4. So Ti is allowed to wait only if it has timestamp smaller. So now if you see 2 is smaller than 4, so correct. So now T2 will wait. ठीक है, but if in case T6 would have asked, if that wait and die condition ही होती, ठीक है, wait and die होती, so T4 is holding a resource. T4 के पास एक resource है आपका R. Now if T2 wants to request for this R, so T2 will wait. Why it will wait? Because 2 is smaller than 4. But if T6 would have requested for this, then it would have rolled back. Why rolled back? Because the timestamp of T6 is 6 and it is greater than 4. So what is happening? अगर 2 request कर रहा है, so 2 is less than 4, wait. It will wait. Otherwise what will happen? If 6 is requesting, so 4 is smaller than 6, but the condition is that कि जो request कर रहा है, the transaction that is requesting, it has to be smaller in case of wait die. Okay, so since T6 is greater than 4, so that is why it will die. Is that कि the transaction that is requesting the data item, the timestamp should be smaller than that. ठीक है, and wound weight is basically कि in wound weight instead of smaller you will have larger. ठीक है, यहाँ पे instead of smaller you will have larger. So what the case would have been if T2, T4 and T6 would have requested for this, then what would have happened is कि if T4 was having the process, if was having the resource, so अगर T2 would have requested for this, it would have what? It would have made it ki okay, now you are smaller than me, I'll not give it to you. So this will be wound weight. And what will happen in this case? If T6 would have requested, so it would have waited for this. Now what is preemptive in this case is that कि जैसे ही T6 will come, ठीक है, T6 will come, T4 will give its resource to T6 and itself will go in a preemptive state. मतलब it will take a wound on itself. Means कि you are executing something and as soon as a larger timestamp process come, you will stop in between, you will let the other process enter and you will wait now. ठीक है, so in basic it will say that okay, a wound has occurred on T4 and it is letting T6 execute and it is waiting now. That is wound wait. Okay, so wound wait के case में you will have a larger timestamp. If the requesting transaction is larger, it will be allotted. Otherwise, in wait die you have to make sure that smaller वाले को ही allot हो. So please just remember this, smaller and larger. कि smaller अगर definition में है, it is your wait and die. अगर larger definition में तो it is wound and wait. Yes, correct Deepak. So this is what I'm saying कि wound wait में what will happen is कि larger timestamp का process आया, right? So larger timestamp process, what will it will do? It will take the resource from the process that is currently holding it and this will have a wound on itself. Okay, and in wait and die, the process with smaller timestamp will wait, and when it will finish, when the currently holding process will finish, then only it will give the resource back to the process that is waiting. So these are your two things, wait die and wound wait. So now global locks. So what is global locks? Global locks synchronize access to local resources, synchronize access to global resources, are used to avoid local locks, prevent access to global resources. What do you think it is? Very easy, बहुत ही easy है. So this is option number B, synchronize access to global resource. Obviously जो global locks होंगे आपके, they are basically for your global resources. जो आपके जो items, जो आपके data items global हैं, उनके लिए अगर उनको you have to lock, so that for that purpose you need global locks. Now in conservative two-phase locking protocol are transactions. So basically they're asking you the definition of conservative two-phase locking protocol. Conservative two-phase locking protocol, a transaction should release all the locks only at the beginning, should release exclusive locks only after commit, should acquire all the exclusive locks at the beginning, should acquire all the locks at the beginning of transaction. So what is the definition of conservative two-phase locking? Answer is C. Okay, correct answer is C. So now basically if you see, let me just write it. So if you see, what is basically two-phase locking? So they are your lock-based protocols. Okay, so in your lock-based protocols, you know that there are two types of locks: shared locks and exclusive locks, right? So in lock-based protocols, we have two-phase locking, that is 2PL. ठीक है, two phase locking protocol. So two phase locking, what we have four types. One is your basic 2PL. Okay, other one is your strict or conservative 2PL. Then we have strict 2PL, and then we have rigorous 2PL. Okay, now 2PL, you have to remember this, that 2PL, that is two phase locking protocol, it always ensures serializability. Okay, this is what you have to remember, that 2PL will always ensure serializability. Okay, now 2PL में what we have, basic 2PL and all this. So locks आपको पता है कि we have two types of locks, shared lock and exclusive lock. Now let us talk about what is basic 2PL and all that. ठीक है, so 2PL में what happens is, there is that in basic 2PL में what we have two phases. Why it is 2PL? Because we have two phases. What are those phases? Growing phase and shrinking phase. Okay, so growing phase says that in growing phase you can only acquire the locks, and in shrinking phase you can only leave the locks. Okay, so once your growing phase is over, after growing phase you cannot acquire any lock. Okay, this is your growing phase and shrinking phase. Now, what are the disadvantage of this basic 2PL? It can cause deadlock. I'm not going in much detail, just giving you a brief overview. Okay, so this is your basic 2PL. Now what is conservative 2PL? Conservative 2PL में the major thing is that all locks, all exclusive locks must be acquired at the beginning. This is your conservative 2PL. Now what about strict 2PL? Strict 2PL says that all X mode और exclusive mode, ठीक है, X mode को exclusive mode भी बोलते हैं, all X mode locks taken by transaction must be kept until the transaction commits. So this is your strict 2PL. Then what is rigorous 2PL? Rigorous 2PL says that all locks must be held until transaction commits. So these are your four types of 2PL. So one is your basic 2PL, that is having two phases, growing phase and shrinking phase. It can cause deadlock. Then we have conservative 2PL, that all the exclusive locks must be acquired at the beginning. Then we have strict 2PL, that all the exclusive mode locks that are taken by the transaction must be kept until the transaction commits. And rigorous says that all the locks, whether it is shared or exclusive, all locks must be held until your transaction commits. Okay, so 2PL, that is your two-phase locking protocol. It only ensures always your serializability. So if your schedule is serializable, it will always be in two-phase locking. Okay, so this is the basic of your two-phase locking protocol, 2PL. Just wait. So the correct answer is option number C. That is, all the exclusive locks at the beginning. Must share all the exclusive locks at the beginning of the transaction. Next is this one. This is your gate question. In this, they have given you two transactions, T1 and T2, and they're asking that these are your options A, B, C, and D. So out of these four options, they're saying that which of the following just a minute. Just a minute. Now visible? So question number 51 में they have given you two transactions, T1 and T2, and they are asking you that which of the following schedules that is given below, ABCD, out of ABCD, which one is the one that is equivalent to the above schedule. So equivalent के लिए I have told you that what conditions you have to see. What were the conditions that you have to see for if your two schedules are equivalent? There were three conditions. Yes. What were those three conditions, everyone? We have already discussed this in the class. If I have to check whether two schedules are equivalent, what were the three conditions that we check? अभी 51 कर लो, फिर I'll tell you 52. What were the three conditions, everyone, that I told you for equivalent? Initial read, then updated, and then final write. Yes. Now what you have to do, simply you have to check, you have to match this schedule with these options, and you have to see that which of the following are equivalent, which of the following is equivalent to this schedule given us in the question. Try it. Very easy, बहुत easily कर सकते हो आप. Correct. What will be the answer for this one? The first answer that is coming is option number C. Let's check for C. Updated read. First let's check read. So read A is done by T1, so T1 correct. Read B is done by T2, correct. Read C is done by T1, correct. Read D is done by T2, correct. But now if you see here in this given transaction, they have seen that first T2 is reading D and then T1 is writing D. Matlab read write for D is first T2 is reading, but in this case it is like this. First T1 is writing and then T2 is reading. So that is why option number C is wrong. I hope you got this point, everyone. Why option C is wrong? In the given schedule, T2 is reading D and then T1 is writing. But here T1 is writing D and then T2 is reading it. So that is why option C is wrong. Let's check for option number D. So read A, correct, read A. Read B, correct, read B. Read C, now C again. In this we are having first T1 is writing and then T2 is, first T1 is reading and then T2 is writing. If you see here, first T2 is writing and then T1 is reading. So this is what is wrong. So that is why D option is also wrong. What about A and B, everyone? C and D तो गलत हो गए. What about A and B? Out of A and B? If you see option number B, final write of B is done by transaction T1. But if you see here, final write of B is done by transaction T2. So that is why this is also wrong. So the correct answer is option number A. You can check A. Everything is as per this given schedule only. If you check this, it is according to the given schedule only. Correct, everyone? So correct answer is option number A. समझ में आ गया how you will find whether the two schedules are equivalent or not? You just have to keep in mind that these three things should always be taken care of whenever you are working. Okay. Now, moving on towards the next question. Which of the following concurrency control protocols ensure both conflict serializability and freedom from deadlock? Which one will ensure both conflict serializability and freedom from deadlock? So I have told you just now that two-phase locking ensures only serializability and it is having the problem of deadlock, right? So two-phase locking to nahi hai. So timestamp ordering is the one that ensures serializability and freedom from deadlock. ठीक है? Two-phase locking में सिर्फ और सिर्फ serializability होगी, deadlock occur हो सकता है. Deadlock can occur in your two-phase locking. Now this one, what they are saying is they have given you 4 transactions, they have given you the order and they are asking you कि which of the following statement is correct. हाँ जी, 2PL में आप कोई सा भी 2PL देख लो. आई थिंक रिग्रेस वाले में भी देयर इज नो फ्रीडम फ्रॉम डेडलॉक. जस्ट लेट मी चेक, आई विल एक्सप्लेन टेल यू. 2PL के केस में भी इफ यू सी योर कंजर्वेटिव में डेडलॉक डज नॉट इट में लीड टू स्टारवेशन. ठीक है. सो रिग्रेस हो गया आपका, रिग्रेस में डेडलॉक एग्जिस्ट करता है. कंजर्वेटिव में इट इज दैट डेडलॉक डज नॉट एग्जिस्ट बट दे कैन लीड टू स्टारवेशन. ओके, सो बाय डिफॉल्ट यू विल ऑलवेज टेक योर 2PL इज बेसिक 2PL ओनली. ठीक है. Strict and rigorous will have deadlock. Conservative will not have deadlock, but it will cause your starvation. So first we'll draw simply T1, T2, T3 and T4. We'll simply check. So if you see, the diagram will be somewhat like this. Then you will have this. Then you will have this. Then this. And you will have this. So there is, I think, no cycle. Right? है ना? So there is no cycle. No cycle means that it is conflict serializable. ठीक है. So now we have to check for recoverable. So I have over here, if you see, read Z. First, if I check about read Z, so read Z is only read by this transaction T2. So it is not a dirty read. ठीक है. But if I see about here, see it is read X. So read X is what? It is read after it is being updated by this one. है ना. पहले यहाँ पे अपडेट हुआ है and then we are having this read X. So now if you see, this one has committed before. So okay, no problem, it is recoverable. And if I see for this one, read Y, so this one has been read after this one. So this is also committed before and then it is committing. So this is recoverable. So we have already studied the definition of recoverable in the previous question. From there we can say that S is both conflict serializable and recoverable. Clear ho gaya wala? I think now you have no problem, at least in recoverable part. If you have to check whether a schedule is recoverable or not, you will be able to do it easily. Right? Hello Pooja. Now this question is, for the given schedule, which of the following is correct? So this is the schedule given to you. Read A, read B. This is your, you can say it as transaction T1 and this is your transaction T2. If I draw a line over here, you have to tell whether it is serializable and it can occur in a scheme. Matlab, you can do this, you can apply two-phase locking protocol on this schedule or not. So this you have to do now. So how you will do? Try it. Good. So that is why now questions are very important, because some concepts which are very tough when we talk about, you know, theory, but when we do questions, when we apply questions on them, they are very much clear then. So that is why practicing questions is very, very important. What about this one? Simply first you will try to draw a graph. So T1 and T2, right? So what we can see, what the type of graph we will have. So read A, write A. So 1 say 2 you will have 1, right? Then read B, and 2 say 1 you will have. So this is what? This is a cycle, and when cycle exists, it is not conflict serializable. Now, if you see this thing, if you remember this, that when what I have told you earlier, that if I have a two-phase locking protocol, it is what? It is always serializable. serializable. Yes, this is what we have read, that if we have a two-phase locking protocol, if we have two-phase locking, it will always be applied on serializable, that schedule, that is, it will always ensure serializability. But my this given schedule, it is not serializable. So since my schedule is not serializable, so 2PL cannot occur on this schedule. समझ में आ रहा है everyone? Why not occur होगा? Because if this would have been a serializable schedule, then two-phase locking would have definitely been applied on it, because two-phase locking is always ensure serializability. But my this schedule is not serializable, and since it is not serializable, that is why it will not have 2PL on it. Got my point, everyone? Just use this concepts that we've already studied. Do not dive for new concepts. Whatever you have studied is enough for you to do these questions. 2PL में we know that 2PL will always ensure serializability. मतलब if there is any schedule that is having 2PL on it, it will definitely be serializable. ठीक है? Now this schedule is not serializable. So since it is not serializable, we cannot apply 2PL on it. Otherwise this condition will not be verified. It will what you say, इसका अब reverse हो जाएगा. That now one time we are saying that 2PL is always ensuring serializability, and now we are saying that a non-serializable schedule is applying 2PL protocol. So that is what you have to remember, कि 2PL है तो serializability है. अगर if there is no serializability, there is no 2PL. ठीक है? So that's it for today. ठीक है? Tomorrow we will we'll take the questions of your disk that we have now, file system, file structure. So we'll do questions on this, that is your B tree, B plus tree, and plus I'll see certain questions from this topic as well, whether if there are any extra topics or not. And after that we will start with your data structure. Okay, and very soon I'll be giving you short notes on, I am not decided the subject, but I think it will be related to paper 2. Paper 1 में teaching aptitude के short notes I have already provided you. Now I'm thinking for paper 2, which subject do you need short notes for revision? Subject, any subject, any topic that you need short notes to revise on, anything. If you have any, like teaching aptitude, many of you were saying we need notes and notes, so that is why I provided that. Paper 2 में से कोई है ऐसा topic? Is there any topic that you need short notes to revise on? Think about it, okay? And then do tell me if there's any topic like this that exists. You can tell me on the Telegram group. आपके पास है पूरी notifications. And yes, please do download the Android app as well, okay? So that you can be updated, you can be notified about the courses and about everything. We will have evening class today as well, ठीक है? 6 PM पे ही है फिलहाल के लिए class, प्रियंका. 6 PM is the time for now, and we will complete today the paper. We'll complete it. I'll try my best कि आज हम उसको complete कर दें. We have done till 35. 15 questions are also there now, so we'll do it quickly. And then from tomorrow or from day after tomorrow, we'll see to it. We will start with, what you say, we will start with the 2018 paper 2, so that we can practice more and more papers, and with that we will be able to understand the concepts as well. Ma'am Cloud, see, AI के जो topics आपके बच गए हैं, ठीक है? AI is, I'll try to provide you notes on AI, but we will do the questions and paper में जो questions आए हैं, and with the help of those questions I'll try to explain you the concept of AI, ठीक है? And cloud computing, yes, cloud computing के notes मुझे आपको देने हैं, so I'll give it to you within 2-3 days. Okay, just give me time of 2-3 days. I'll give it to you. Thank you, Deepak. AI and SE. See, AI and SE में तो कोई short note में क्या है ना, short notes is basically, I'll try to provide short notes for SE, ठीक है? I'll try. Just give me some time. I'll try to provide short notes for SE. And SE में भी फिर it will be happening topic wise, because I cannot include all entire SE in one division notes. I'll try my best. I'll see to it, ठीक है? Okay. So for evening, we'll be discussing the remaining paper of 2018 that is left, and then we will see what next we will do, okay? नेक्स्ट विल बेसिकली पेपर 2 होगा आपका 2018 का. लेट्स सो just practice your concepts, practice the questions, revise your concepts. ठीक है, and if you have any doubt you can always ask me. चलो, that's it for today. See you all in the evening.